everyone, and welcome to this explainer. Today, we're putting on our detective hats to decode the unseen villains lurking right inside your workplace. We are diving deep into the microscopic and the invisible, those chemical and biological agents that just surround us every single day. But before we even step onto the crime scene, I want you to stop and ask yourself a pretty serious question. What microscopic hazards might you be breathing in, touching, or absorbing right now without even realizing it? Because whether you're in a bustling factory, a pristine lab, or honestly, even a standard office, you are constantly interacting with complex substances. And to truly protect ourselves, we have to understand their shape-shifting nature. It's crazy to think about, but chemical threats actually change their modus operandi entirely based on temperature and pressure. Most substances can exist as a solid, a liquid, or a gas, and that physical state completely dictates its attack vector. Gases, for example, are perfectly primed to be breathed directly into your lungs. Liquids easily splash, absorbing right through your skin. And handling solid chemicals? Well, that frequently leads to cross-contamination, where the substance ends up on your hands and eventually right in your food. So let's profile some of these airborne culprits. It's fascinating because very fine particles act exactly like gases, and the variety of these microscopic threats is just staggering. We have coarse grinding dusts, we have fibers like asbestos, which have a really unique ratio, being 3 times longer than they are wide. Then there are microscopic metal fumes created by vaporizing molten metal during welding, mists from spraying, and smoke-carrying combustion products. And here's the ticker. The sheer size of these particles is the exact metric that dictates how far down into your respiratory tract they can actually travel. Now, moving over to our biological suspects, these are a completely different breed of threat. First up, bacteria. These are microscopic organisms equipped with circular DNA that cause nasty diseases like MRSA. Then we have viruses, which, fascinatingly enough, aren't even truly alive. They're up to 100 times smaller than bacteria and act like tiny hijackers, taking over your healthy host cells to replicate, which makes fighting them incredibly difficult. Finally, fungi. In the workplace, breathing in fungal spores can trigger severe respiratory conditions, like the extrinsic allergic alveolitis that's commonly known as farmer's lung. So, with all these chemical and biological threats floating around the globe, regulators realized they absolutely needed a universal warning system. Enter GHS, the Globally Harmonized System, which was adopted over in Europe as CLP. This standardized language of classifications and red-framed labels ensures that no matter where a chemical is produced in the world, a worker can instantly recognize the danger. The packaging really holds all the secrets, and the pictograms on them are your absolute first line of defense. Let's run through these visual clues rapidly. That red-framed exploding bomb. It's a dead giveaway that the substance is highly explosive. It means the chemical is fundamentally unstable and demands the absolute highest level of careful storage to prevent a catastrophic detonation. Spot the flame, and you guessed it, you're dealing with a highly flammable material. The gas, liquid, or solid inside that container can easily ignite. Seeing this symbol is your immediate cue to strictly separate the substance from any sparks, open flames, or heat sources. Then we have the corrosion symbol, which is terrifyingly literal. Acid dripping from test tubes won't just destroy a solid metal bar, it destroys human living tissue on contact. It's a stark reminder that a corrosive substance won't just cause a mild, annoying rash. It will cause severe, irreversible chemical burns. The classic skull and crossbones. This is the ultimate calling card for severe, acute toxicity. When you see this, you are dealing with a chemical that can cause permanent damage or even death at very low levels of exposure. Whether it's swallowed, inhaled, or just touched, it is the universal sign for an immediate, life-threatening poison. Now, the silhouette pictogram showing a person with a radiating, damaged chest is actually one of the more modern and critical additions to the lineup. It points to hidden, long-term systemic dangers. We're talking flags for carcinogens, mutants that cause genetic defects, or severe respiratory sensitizers that might literally take years to show their full devastating effects. And finally, the exclamation mark. This one flags a harmful substance or an irritant. While it's slightly less severe than the skull and crossbones, meaning it probably won't be immediately fatal at low doses, it still absolutely demands preventative action. It can cause skin irritation, drowsiness, or respiratory issues, and should never, ever be ignored. So how does all this come together in the real world? Well, if we compare a pure substance against a mixture, the difference is clear.
A pure acetone label uses the severe danger signal word alongside the flame and exclamation pictograms because it's a highly flammable, pure substance. On the other hand, a mixture like Super Clean, containing less than 5% of a hazardous chemical, utilizes the less severe warning signal word with just an exclamation mark. The language scales directly with the severity of the threat.
Beyond just those pictures, the label provides specific instructions broken down into two main categories. Hazard statements, or H statements, tell you exactly what the threat is, like fatal if swallowed. Precautionary statements, or P statements, give you the crucial instructions you need to safely handle it, like use only outdoors. Simply put, one tells you the crime and the other tells you how to prevent it.
Now, the crucial thing to remember here is that toxicity actually strikes in two fundamentally different ways. Acute effects happen suddenly, usually within minutes or hours of a single high-dose exposure, like inhaling a cloud of acid vapor that immediately burns your throat. Chronic effects, however, are stealthy. They slowly accumulate over months or even years of repeated, low-level exposure. You might not feel a single thing today, but years later, it manifests as permanent lung scarring or severe nerve damage.
Honestly, the easiest way to conceptualize this is by thinking about alcohol. Think of acute toxicity as the immediate hangover from a really heavy night out. You get the nausea and the headache right away. It's intense, but it's temporary. Chronic toxicity, on the other hand, represents the severe diseases built up over a lifetime of excessive drinking, like coronary heart disease or cirrhosis of the liver. The substance is exactly the same, but the duration and the pattern of exposure change the medical outcome entirely. To make sure we aren't accidentally accumulating these toxic doses over a long career, safety regulators establish what are called workplace exposure limits, or WELs. Think of them as a scientific speed limit for your lungs. They are highly specific, time-weighted average concentrations of hazardous substances that are allowed in the air over an 8-hour working shift. It's a hard cap, designed to ensure that even if you work with a chemical every single day until retirement, you won't suffer adverse health effects. Okay, so we know what the hazards are, we know how they're labeled, but how do these microscopic villains actually manage to break into your body? Well, they exploit 4 main routes. They can be ingested when you accidentally swallow chemicals from contaminated hands. They can be injected if your skin gets punctured. They can be absorbed, seeping directly through your pores. And finally, the most dangerous route of all, they can be inhaled. Inhalation is, without a doubt, the undisputed king of occupational hazards. Breathing in hazardous agents accounts for a staggering 90% of all toxic illnesses in the workplace. Because we naturally breathe in and out thousands of times during a single shift, our lungs essentially act as a wide-open door for airborne dusts, fumes, vapors, and biological agents. Once these agents are inside, the damage is essentially twofold. Breathing them in causes horrific local damage right in the respiratory tract, resulting in conditions like bronchitis, severe asthma, and irreversible scarring. But it doesn't stop there, not by a long shot. Many chemicals easily cross from the lungs directly into the bloodstream, traveling through the body to systematically poison your liver, your brain, or your kidneys. So now that you possess the skills to decode these critical warnings, read the pictograms, and truly understand the pathways of attack, you have to look at your own workspace with completely fresh eyes. If 90% of workplace poisonings start with a single unthinking breath, what invisible threats did you just inhale today? And more importantly, are you truly protected? Keep decoding the world around you and stay safe out there.